Okay, a couple of you had emailed me some questions about the homework from section 4.2 and two problems in particular, so I just wanted to run through them really quickly here. And I will point out these problems use properties that you learned in 171, and we'll go over them really quickly here in case people need a little bit of review of them, because they are properties that we actually are going to use for these trig functions throughout the semester, so they are important, and they're important in math in general. So first off, number 70, which says just to use the properties, use the even and odd and periodic properties of the trigonometric functions to simplify. So for this, like I said, just applying the properties that we know or that we're supposed to know and remember from 171. Secant of t plus 2 pi minus secant of negative t, and I want to simplify that. And first off, here, t plus 2 pi. I know that the secant function, secant's reciprocal of cosine, and the period of cosine is 2 pi, which means the period of secant is 2 pi. And we know that means the idea is, say, if I have a 30-degree angle right here, I get that point right there, and that tells me my secant. Well, if we're talking about cosine instead. If I know the cosine, the sine, anything for that point right there, for that angle, well, if I add 2 pi to it, that's adding 360, I end up right back where I started, which means I'm going to get the exact same sine and cosine values at that point. So all that really tells me is, since the period of cosine, and by extension secant, is 2 pi, secant of t plus 2 pi is the exact same as secant of t, because adding 2 pi to t gets me right back where I started. So this just simplifies to secant of t. Here, I have secant of negative t, and we care about the even and odd nature of these trig functions, and for the purposes of this, I know secant is the reciprocal of cosine, and you should know this for secant, but we know the trick. I can graph my cosine wave, which looks like this and looks like that, and I then know if I want to graph secant, I just kind of make these u's in the ends like this. And I actually don't need to do this if I understand the properties here, but visually this can help. In terms of even and odd, well, if we remember 171, there's algebraic tricks to determine if something is even and odd, which we'll go over in a second. But the other way of actually looking at this is looking at how it's symmetric. And for the purposes of this, whether you're talking about the cosine wave or by extension the secant, they're symmetric about the y-axis. For the cosine, if I take this and flip it over there, I get the same thing. If I take this and flip it, or this and flip it, I get that. Which means this is symmetric about the y-axis. And if you remember 171, that means that cosine and secant are even functions. And the algebraic definition means for an even function, f of negative x equals f of x. Which means, if you remember 171, you would have something like, we'll go with f of x. F of x equals x squared, but f of negative x equals negative x squared, but when you square and negative, the negatives cancel, and I get x squared, I get the same thing. That's what makes it an even function. It really just means I can drop the negatives here because I get the same thing. It works the same here. Since secant is an even function, secant of negative t is the same as secant of t, and the negative just disappears. But now I have secant of t minus secant of t, which just gives me 0, and that's it. That's the first one. Now I want to do the other one. So for number 72, cotangent of negative 3t minus 3 cotangent of 3t plus pi. And I want to simplify that. And there's part of me that wants to point out here, we're talking about a cotangent wave, which we understand is different than sine, cosine, secant, and cosecant, meaning they all have period 2 pi, tangent and cotangent have period pi. But now I know all that tells me is this cotangent of 3t plus pi, the pi isn't going to change my answer at all because it has period pi, so I can just drop that pi right there. So then I get cotangent of negative 3t minus 3 cotangent of 3t. But then now I have a negative on the inside, and I know as far as it goes, I want to use the properties of even and odd for this. And here, we'll just use the tangent wave because that's the one we're more used to. But tangent, like this, that is not symmetric with the y-axis, but if you remember 171, that's symmetric with the origin. Take this, flip it, and the graph for cotangent would work the exact same. But if you remember 171, what that means is this is not an even function like cosine and secant that we just did. This is an odd function. And the definition for odd functions, we just did even. F of x equals f of negative x. For an odd function, f of negative x equals negative f of x. And what it means is, for the even function, you can just drop the negative on the inside and get the same value. For odd functions, you can't drop the negative, you pull it outside to the front. Which means cotangent of negative 3t is negative cotangent of 3t minus 3 cotangent of 3t. Now those are the same. Negative cotangent 3t minus 3 cotangent 3t is negative 4 cotangent 3t. And I think that's the only two we wanted to go over. Yes, good. And now that's simplified. And for, well, I guess in this semester, for the next several weeks, we're going to be going through these, and there are a lot of properties and identities and things like that that we're going to learn that will allow us to simplify and manipulate these things right here. And they are incredibly important and useful. There is the part of me that says, a lot of times if I'm solving a problem, for the purposes of this class, I don't necessarily need to use the even and oddness. Here we're studying the properties because they are important mathematically. But there is a large section of this class that will talk about verifying trigonometric identities. It's essentially doing a lot of algebra. And we will need to use all of these properties in order to do it, which is why we're going over them. And I do stress, as will become apparent a few times in this semester, there are some things that are incredibly important in math. Knowing the even and oddness of a function is really, really important. But from a problem-solving perspective, I can solve a problem in other ways other than using an even and oddness. But for the purposes, like I said, verifying trigonometric identities and things like that, we need to know these properties, which is actually why we're going over them. And my point, just to kind of make this clear, if I had sine of 30 degrees plus 360 degrees. Now I could certainly say, oh, the period of the sine function is 360 degrees, 2 pi, however you want to say it. So sine of 30 plus 360 is the same as the sine of 30. So because I can just drop that, and then I know the sine of 30 degrees is 1/2, and there's my answer. But ultimately, if I actually had this problem, I could just say that's the sine of 360 plus 30, that's 390. Oh, if I then graph that, that's 360 degrees, that's 390 right there. Oh, that's a 30-degree angle, so this is really just sine of 30 degrees, and then get the same answer. And that's what I mean. For this class, a lot of times when I have the numbers, I don't necessarily need to use the property. I can just solve the problem out, and I'm aware of that. But there are certain parts of math in general, ultimately, when you get to higher level math, and for the purposes of this class, when we get to this thing called verifying trigonometric identities, where we need to be able to use properties algebraically. Oh, that's an odd function, so I can pull the negative out. Oh, that has period pi, so I can just drop the pi. Oh, it's an even function, so I can just make my negatives disappear. So we just want to make sure we understand all these properties so that we can work with them. And like I had said, if there are other questions that randomly pop up on your homework or on your labs, feel free to email me and let me know, and I'll just keep making extra videos for you to watch, and I'll throw them under our class announcements so we have them. And yes, or just any other lecture videos that you have questions about that you would like me to do more lecture videos of, just feel free, email me or stop by the library where I'm tutoring.